So interface. So interface is a blueprint of a class. Blueprint in the sense it will not be having any implementation. Just it will be a set of some rules, right? It specifies what a class must do, or in other words, an interface defines a set of a specification class must implement, right? So it is just defining a set of rules. So those rules need to be implemented by a particular class. What is the use of interface, right? First use is it is used to achieve abstraction. Abstraction we have seen. Abstraction is nothing but hiding a implementation part. That is abstraction. So by using abstract classes, as I already told you, by using abstract classes, few methods will be made as abstract and a few methods will be a concrete, right? So as a few methods are a concrete, you cannot say your particular class is a completely abstract class, right? So whereas the interface, as it don't allow any of the methods need to have some definition with respect to that, so this interface will provide you a complete abstraction, right? It supports multiple inheritance. Did we come across this particular term anywhere while discussing inheritance? While discussing inheritance, we said that multiple inheritance is not possible. Multiple, right? We said like there will be ambiguity if you are going with a multiple inheritance. Multiple, that means one particular class need to take a value from a more than one particular class. Multiple inheritance. And we said that multiple inheritance is not supported with respect to Java, right? So that is not supported with respect to Java if you are using just a classes. But if you are using interfaces, you can achieve multiple inheritance. We will see what exactly is a multiple inheritance if you don't remember also, and we will see how that particular interfaces will help you in achieving a multiple inheritance. The last point is it can be used to achieve loose coupling. What is this loose coupling? Okay, so with respect to technical aspects or programming strategies or a software engineering terminology, this particular loose coupling is nothing but there should be some level of independence. Independence in the sense, at a one place you are defining a rules, and at the other place you are defining some classes for that, right? So with respect to interfaces, what we are doing is when we are defining an interface, we are just specifying what are the things need to be there with respect to a implementing class, right? Later, it is a responsibility of each class to implement all those interfaces. Loose coupling in the sense, later if you want to modify also, you can, if there is any problem also, you can go to that particular class, then you can check what might be a problem with respect to implementation. Or in other way, if you want to know what exactly your program is going to do, if you look at just an interface, you can decide what exactly the program is going to do, right? Interface is nothing but a kind of a menu for you, right? So by looking at a menu only, you can decide what are the other classes are going to do with respect to this particular program, right? So this is called as loose coupling. Loose coupling in the sense there is no that much strong bonding between the classes and objects, right? So that is software engineering terminology. So what I mean to say is loose coupling in the sense there will not be any strong bonding between the classes and objects, and there is no dependability exactly in the terms. If I want to say in exact terms, there will not be that much dependency with respect to classes and objects, right? So things will be a bit transparent. Loose things will be a bit loose. You can easily understand what exactly the class is doing, what exactly this another class is doing. That is loose coupling. Okay, so defining an interface. How you will be defining interface? That means what is the syntax of that particular definition of interface? An interface declaration consists of modifier, public, or no specifier. That means if you are not specifying also, it will be a public. Interface name, so means first you will be having a modifier specified, then you will be having an interface name specified. So after that, comma separated list of a parent interfaces. That means this is talking about a general syntax. So one interface can extend more than one interface also, extension of interfaces is available, like how you have extended the classes. So in a similar lines, you can extend interfaces also, right? So in a general, it will be having a modifier, access modifier, followed by interface, that keyword. Then you will be having an interface name, what are the name you want to give for an interface. Then you will be having a comma separated interfaces, which you want to inherit a few methods from a parent, right? So after this particular statement, you will be having an interface body. Interface name, bracket, any number of a final or a static fields, any number of abstract method declarations, right? So any number of default method, any number of a static method, right? So with respect to interfaces, only these things are allowed to be written in an interface. You cannot write any constructors in an interface. If you are defining any field, then that particular field will be final and static, right? So if you are defining any method, by default that particular method will be an abstract method, right? So from a version 1.8 onwards, you are allowed to put this particular final and the static fields and this particular default method and the static methods, right? So previous to 1.8 version, so only abstract methods were allowed with respect to interface, but later on with the version 1.8 onwards, so you can include final and static fields, default method, static method. Clear? So this is syntax of your interface. An interface is a collection of abstract method. It can never be instantiated, so does not contain any constructors or instance fields that I already told you. The only fields that can appear in an interface must be declared both static and final. Not extended by a class. Interface means if a class has to use this particular interface, means it has to implement itself. It cannot directly extend. Not extended by a class, but it is implemented by a class, right? An interface can extend multiple interface. Have a clarity with respect to these two definitions. One particular class can implement interface. An interface can extend multiple interfaces. Class cannot extend interface. Class must implement interface, whereas interface can extend interfaces. We'll see an example, don't get confused. If we are writing something like this, means interface polygon, string color is equal to blue, void get area, you will be writing this particular statement. But internally, how the compiler will look into this particular declarations is something like this. Interface polygon, you have written just a string color, but internally it will be a public static final string color is equal to blue, right? So I already told you, whatever constants you are going to declare with respect to our interface, all those things will be a by default final and a static, right? So this particular void get area method, internally it will be something like public abstract void get area because all the methods with respect to interface are a public only. Clear with the points? And again I'm telling you, all these points we have covered already. Extra whatever has been introduced is this particular variable kind of stuff, and that variable I'm saying that will be a by default static kind of final, right? Interface polygon, so this particular interface has got a one abstract method which is called as void get area. So and it is taking a two arguments, length and a breadth. This is interface polygon. Then you have a class which is called as a rectangle which implements that particular polygon, right? When it implements, whether a get area method available in a class rectangle, when a class rectangle implements polygon, whether a get area method available with respect to a class rectangle. Now if I want to give an implementation for a get area, what I need to write in a class rectangle? What has to be written with respect to class rectangle? Do I need to write just a wide get area int length comma int breadth? My question is class rectangle implements polygon. Implements polygon in the sense it is implementing this particular interface, right? When it is implementing this particular interface, obviously it has to give a definition for this, right? If you want to give a definition for a get area, what has to be written here? Wide get area arguments comma arguments. That is what my question. Do we need to write just a wide get area, or do we need to clearly specify that it is a public wide get area? We have to clearly specify that public wide get area, because if you are not writing a public, I already shown you error saying that this particular method has not been overridden a method, right? So if you are defining that particular method, it should be a public wide get area. So whatever the arguments are there, that arguments, you are just calculating length and the breadth of that. Right? In an interface, you had a one abstract method. By writing a one particular class and implementing that particular interface, you gave a definition for a wide get area, right? So this is a simple example. So your interface is done. That is, the interface is having only one method, and that one method you are implementing using a class rectangle, right? So now whatever the requirement was given with respect to interfaces, so that has been achieved by using a class rectangle. Right? So now you can easily write, so means cleanly write that particular main method. So you can create object of a rectangle. Using object of a rectangle, you can call a get area method. Right? Main method, creating object of a rectangle. So by using object of a rectangle, you can call a get area method. Clear with example, right? We have already seen one example which was having a two methods. Now we are just seeing a one particular example which is having a one method in an interface. Okay. So relationship between classes and the interface. This is a very important aspect that you need to remember. If you are not remembering this particular scenario, it will be a very uncomfortable in writing where to write implements, where to write extends, right? When you have a classes, when you have a pure classes, then only extends will be used, right? You can extend a property from a parent to child. This is class extends a class. Class extends a class. That means this particular child class will get a properties from your parent class, right? But if you have an interface, then you need to implement that particular interface. Here also it will be something like a parent-child relationship itself. Your interface will act as a parent and this particular class will act as a child. Right? So from the parent, whatever you are getting in this case is nothing but your abstract methods and few constants which are declared as final and static. Right? So class extends class, class implements interface, and the interface can extend the interface. Right? You cannot write interface A implements interface. Cannot be written. Interface will not implement any other interface because it cannot have any concrete methods in it. Right? Who can give an implementation? Only class can give an implementation. Right? If you are using an extends keyword, then the next argument after extends, there should be a class itself, because class can extend the class. If you are writing an interface followed by extend, interface I extends, then you can give n number of interfaces. We will say example, don't get confused. The next topic is using interface references, right? So before I proceed with this particular topic, I would like to show you a previous example, whatever we have written in the morning session, then I will go to this particular point. Right. So here is an example which we have discussed in the morning session. Here we had a one interface which is having a two methods. Then one abstract class was giving a implementation for one particular method. Another class gave a implementation for another method. Right. So here in the main method, we have created object of a chef1, that means this particular class. So by using this particular object, we have called a methods called a dosa and the idli. Right. So now what topic we are discussing is, I don't wanted to create object of a chef1. I don't wanted to create object of this particular chef1. What I will do is, I will create reference object of a person. Reference object of a person. What I mean to say is, let me remove these particular statements. Right. So what is our interface name? Our interface name is a person. Right. Person P is equal to what I have created, a reference variable with respect to interface P. Now what I say is new chef1. Can we write something like this? Can I use my parent class reference? Can I use my parent class reference to hold the object of a child class? Right? I can use my parent class reference. I can use my parent class reference to hold the object of a child class. This is valid. This we have seen even with respect to abstract classes also, right? So the same thing is valid with respect to interfaces also, and the same concept has been explained here. Okay, using interface reference, that means I'll be creating a reference of that particular interface. By using that, I'll be accessing of methods with respect to that particular reference. Example. I have an interface which is called as an animal, and there is an abstract method which is called as a sound. Right? Now, when there is an interface, obviously there should be a class which implements this particular interface. Correct? So let us create a class and which implements this particular sound method. There is a class called a dog which implements this particular animal interface. Right? So which method it has to override now? That particular void sound. If you want to override, what has to be written? Public void sound. Right. So wrote that one and gave us some definition. I am done with the interface, done with the abstract method in the interface, implemented that particular interface by a class called a dog. Interface is done, implementation is done. Now let us see the main method. Main method is there. What is our topic? We are discussing something like using interface reference. Using interface reference in the sense, what need to be the first statement here? What is our interface? Animal, right? Animal some sorry, animal some object name is equal to new dog, right? Parent class reference, child class object. This is what I have to do. By using that particular reference object, I'll be calling this particular sound method, right? Animal object is equal to new dog. I am using a parent class reference for holding a child class object. Yes, it is valid and you can use this one. By using this particular obj object, you can call the method called a sound. Right? So this is a valid example, and you can, so means this is a valid program which can be used, means where we are using our interface reference for accessing our child class method. Clear with example, right? If you are clear, I am expecting a small acknowledgement. Then we will see one more small example on this particular topic. Yes. Now, answer me this particular example. I have an interface called animal. I have a class called a dog, which implements the animal, right? How many methods are there with respect to interface? Only one method is there, that is a sound. Now, can I have one more separate method with respect to class dog? We can have, right? So it is not mandatory that whatever method is there with respect to interface, only that one we need to implement, not to write any other methods in a class. Not like that, right? Yes. Now, what I have done is, in a class dog implements this particular public void sound. So this particular implementation has been done. Along with that, I have a one more method, which is this particular eat method is completely for this particular class. This is not a part of any interface, right? Okay. Now, when I create a main method, and I use interface animal reference, that means animal obj is equal to new dog. Animal obj is equal to new dog I have written. What I have done? I have created interface reference is equal to new object, new class. That means constructor I am calling, creating object of this particular class. Now, by using this particular object obj, can I call a method called a sound? Yes, no problem in that. You have seen a last example also, it was a feasible. Now, with respect to same object, obj object, can I call this particular eat method? Here means this particular kind of a stuff we have seen with respect to abstract classes also. Don't get confused. See, this is a parent, this is a child. So from a parent, you have got this particular method called a sound. Okay, so now you are creating a reference of a parent, right? Reference of a parent means it will be holding only the values which is visible to it, right? And I'm saying animal object, right? So this particular object is of a type animal. This particular object is of type animal, right? When it is a type of animal, it can see only this particular sound. How can it see this particular eat? Right? Even though you might be creating object of this particular dog, but what a reference you are storing into, right? Even though you might be having, I have told example by taking a int and a float kind of a stuff. I told like, if you have a float value, yes, float value is a bigger value, right? So dog is having a two methods. Yes, it might be having a two methods. It might be having a bigger value, but where you are putting that particular value, you are putting into an object animal obj, right? So I gave an example somewhere. I think like I wrote a int a is equal to some 2.5. 2.5 is nothing but a floating point value, but you are assigning that floating value to some integer. Obviously that 0.5 will be truncated, only 2 will be there. That means whichever the type it can hold, only that particular value it will hold. It cannot hold a floating point value into that particular int variable, right? So similar strategy will be applicable with respect to interfaces also. By using this particular object, right, parent class reference, you can access the methods which are the part of this particular animal. That means by using obj, you can call the sound, but you cannot call this particular eat method. Not possible, because this eat method is completely belonging to this particular dog class, right? So obj.sound is a valid, but obj.eat is not valid. Right? On compiling, this program generate compile time error, because when you cast an object reference to an interface reference, you can call the methods of interface only, right? So only the methods which are applicable with respect to interface, only those methods you can call. You cannot call class specific methods by creating a reference of an interface. Clear with the example? These things we have discussed with respect to abstract classes also. there was a topic something like parent class references and a child class objects. If you don't remember also, you can go to that particular topic from the playlist. There is a topic something called as parent class reference and the child class objects, right? So the same concept here also. Shall we proceed further? Yes. So before we proceed with the next topic, let us just have a small glance on what are the things we have discussed. We have discussed what is the purpose of interface. We have seen syntax of an interface. We have seen when to use implements, when to use extends on a, so means we have discussed like on a classes how we can use, on a interfaces how you can use the extends and the implements. Then we have discussed what is called as interface references. On interface references, two examples, right? So the next topic which we need to discuss is implementing multiple interfaces, right? So I'll not go through the slides. I'll show you an example, then you will get a clarity, then we will come to the slides. Okay. So topic is a simple itself. Implementing multiple interfaces. Multiple interfaces means you will be having a more than one interface, and a one class should implement those interfaces. Simple, right? Okay. Program. Let me take a new class multi interface demo. I may do some mistake. Let me copy the class name dot java. Okay, so this is my general practice of writing a program. Right, now we are talking about multiple interfaces. Multiple in the sense there should be more than one interface. So interface I1. Okay, so let me call a method called something like a M1. This is one interface. Interface, okay, interface I2, right? So let this have some method called a M2, right? So we are discussing a topic of a multiple interfaces. So class, let me say some x class implements what are the things it is implementing. It is implementing I1 and it is implementing I2, right? So once I write a I1 comma I2, and once I say like implements I1 comma I2, so method M1 and M2 will be taken by this particular class X, right? So what I have to do is I need to give a definitions for those things. I have to write a public void M1. Okay, so I'll write a small print statement, system dot out dot println from M1, right? I'll copy the same thing, paste it here. So means because I need to give an implementation for a M2, I'll be writing M2 from M2, right? So in a main method, I will be creating object of this particular class X. X obj is equal to new X, right? So by using obj, I can call on my method M1. At the same time, I can call the method M2, right? So let us just compile and cross check whether we have done everything perfectly or not. Java C. Oh God. Okay. First pasted this. 1 second. I wanted a file name because I might be doing some mistake in typing this particular file name. So let me copy this particular file name. Copied. Right. Javac dot java compiled file. Right. So what we have done, we have implemented more than one interface. Right. So this was interface I1 and this was interface I2. We have created one class called X, which is implementing both I1 and I2. We gave a definition for both abstract methods, and we were able to create object of that, and we were able to call the methods of those particular class. Clear with the concept of a multi, so means what I can say, implementing a multiple interfaces. Right. Now a small question. Here in the interface I1, I have got a M1, right? Now with respect to I2, can I have a M1 again? Is it possible to have M1 in an interface I1 and M1 in an interface I2? So when I use class X implements I1 and I2, so both interfaces are saying to implement a M1 only, right? So I have given a definition for a M1. Is it possible to write a program something like this? See, observe the things. In interface 1, I have a 1 M1. In interface 2, I have a 1 more M1, right? But in a class X, I am implementing only 1 M1. Fine, right? Okay. So according to this, I don't have a M2, so I'll be removing this particular M2. Now if I compile my program, it should work fine because nobody has given another answer there. Right? Clear with this particular concept? Class X implements I1 comma I2. When you are using a extends, you should never write comma. Right? Only with respect to implements, as it takes a interfaces, you can have multiple interfaces. You cannot have multiple classes. If you have a multiple classes, there might be a possibility of ambiguity. So that is the reason why your Java won't support multiple inheritance. Right? So let us have a quick look what is the content with respect to PPT on these particular multiple interfaces. Right. A class can implement more than one interface. That we have seen with respect to example. In such a case, the names of interfaces should be separated by commas as shown below. This is how we have created in our example also. The class should provide the codes for all the methods declared in all the specified interfaces. Right? If it is not able to provide, then a class need to be made as abstract. Clear? Done. A class shall extend another class, and at the same time it shall also implement one or more interfaces. This is also possible. At one particular point of a time, a class can extend a one particular class, and it can give an implementation for a more than one interface also. Can be possible. If that is a scenario, you will be having a class definition something like this. Class name extends a parent class, implements a interface 1 comma interface 2. Right? So in this scenario, if this particular parent class is having any abstract methods, so those things can be given overridden in a class name, and the abstract methods of interface 1 and interface 2 need to be overridden with respect to this particular class. Right? So at one particular point of a time, a class can extend one class and implement more than one interface. So much bigger class definition, right? But once you know the concept, so this particular, you will understand why they are writing extends followed by these implements followed by interface 1, comma interface 2, right? Now, interface addition, interface abstraction, two interfaces. I have already shown you one example on a multiple interface. Here you have a one more example on a multiple interfaces, right? You have a one more interface called as a multiplication. All these three things are different interfaces which will be having a different methods in those particular interfaces. Now you will be having a one class which implements addition, subtraction, multiplication. You have to give a definition for this add, this subtraction, this multiplication, right? So observe, it is expecting a return type as an int, so you should have a return statement in those definitions, right? So this particular diagram is something like this. This is interface addition, this is interface subtraction, this is interface multiplication, and your class calculator is implementing all these interfaces, right? Public, we have to give a public, so it has been written as a public int add, written a plus b, public int subtract, written a minus b, public int multiplication, written a into b, right? So interfaces have been declared, at the same time class has implemented all those interfaces. Now you can write a main method, right? Create object of a calculator, call all these methods. Simple example, right? Multiple interfaces. Right? Not to waste much of a time, because you know what is a multiple inheritance already, so wanted to quickly finish that particular part with respect to interfaces also. Shall we proceed? Yes. Multiple inheritance in Java by interface. If you have a class A and that particular class is having a method called a show, right? If a class C extends this particular show, no problem, you can create object of this C and you can call this particular method called a show, correct? Yes, no problem in this one. You can write a something like this. Second example. You have a class A, so in a class A you have a wide show, you have another class B, you have a wider display. Now with respect to Java, can we extend both the classes? Can I write class C extend A comma B? Not possible, it will kick, right? JVM will say multiple inheritance is not supported with respect to Java, right? Class C extends these two classes, and the class C will be having both the methods show and the display. Even though in this case you don't have any ambiguity, but if you have a same method in both the classes, then there will be ambiguity. Class A wide show, class B wide show, right? If you are extending this particular class, if you are extending these two classes in a class C, then there will be ambiguity whether you are talking about this particular class A show or a class B show. So this is the reason why your Java don't support your multiple inheritance concept, right? And this problem we have already discussed, but we are just doing a recap of this. And we already said that because as there is an ambiguity in one of the case, so that is the reason why it won't support this particular multiple inheritance concept, correct? And we have said that with respect to interfaces, you will not be having any concrete methods, right? When you don't have a concrete methods, see, you have an interface A, interface B. In an interface A, you have a wide show. Here also you have a wide show. Now, if a class C implements this particular interfaces A and B, right? So in this scenario, it will not be having a two methods, rather it will be having a only one method, which is called as a show. So there will not be any ambiguity, and you can easily create object of a class C, and you can easily call the method called object.show, right? And this is what I have shown in our example also. So in our example also, we had a only one method, which is a M1 in both the interfaces, right? So here we gave a definition for a M1. So this is nothing but multiple inheritance, right? And this particular multiple inheritance in a Java is achieved by the interfaces. You cannot do this one by using classes, right? From a normal inheritance on a classes, multiple inheritance is not possible. But if you are using the interfaces, multiple inheritance is possible, right? If someone asks you a question, can you justify why multiple inheritance is not supported with respect to Java? Are you in a position to explain? Multiple inheritance in Java is not supported by normal classes. Can you justify? Are you able to write the answer for that? Same question, if asked, multiple inheritance is supported in a Java by using interfaces. Are you in a position to justify that? Yes. Clear with the things, right? And these particular abstract classes and interfaces are like related topics. The small difference between these two abstract classes and the interfaces is abstract classes can have some concrete methods and abstract methods, whereas interfaces will have a complete abstract methods itself. It cannot have a concrete methods, right? So by default, the methods will be question in the chat box. Sir, but in this way, methods of both the interface will be reached. Reached. See, interface will just give you what are the things need to be there. That's it. It won't expect that. Means how I need to tell you. Say that is a list given to you. Interface is nothing but a list given to you for the implementation, right? Say for example, you are developing application. That means, say for example, you are doing some function in a home. So in a function, you got a situation wherein which you need to contact two people for finalizing a list of items, right? What I mean to say is, application is one. That means function is one. In one particular function, that means some marriage function, you are asked to contact two people to get the list, finalized list of items, right? So what you have done is, first you went to one person and asked like, what are the things you required for the marriage, right? He will be giving you some list, like these are the items I require. Okay, you will collect that particular list and keep it aside. You will go to another person. You are talking about the same function itself, right? You go to another person, you will ask like, what are the things you require for the function? So same date, same function, both people belong to same family itself, right? So another person will give you another list. Now what you will do? Say for example, if both people have said like idli need to be prepared for 200 people, right? You will be preparing for a 200 itself, right? You will not be saying like, first person has told for a 200, I'll prepare a 200 separate for him and another 200 for a separate for another person. You will not do like that, right? So rule means both person might have specified, but it is the same rule only, right? So what interface, what a class which is going to implement will do is, even if you provide a two list, it says like, okay, both the people have said the same item, so no problem, I'll prepare that particular item, right? Nice question. See, actually, this is how you have to think. So then only it is like we are in a track. Like whatever the things I'm explaining, you are following whatever the way I have said, right? So nice question asked. Right. So let us see. Right. So constants in an interface. This is not that much big topic, a small topic. Generally, why you will be writing a constants in an interface means as I told you already, whatever a constant you specify, that will be a final, right? So if you have any requirement such that whichever classes are there, all those classes should use some set of a constants, right? In those scenarios, you will be specifying a constants in an interface. What exactly I'm talking is, I'll tell you. Say for example, um, you went to a driving license. You wanted to apply for a driving license. When you go to a driving license, they will show you certain symbols. They will say like this symbol is for a no parking, this symbol is for a U-turn, and this symbol is for a some don't overtake. Another symbol is for a don't honk. All those things, right? Now each and every symbol has got some constant, right? If I show this particular symbol, this is the constant. Now, when n number of people come also, those things remain the same, right? Those symbols remain the same. When you have a constant such a way that means when you want to define a more than one constant or a set of a constants which remain common for all the classes, when you need to specify set of a constants which are common for all the classes, right? In those scenarios you will be using constants in the interface, right? I'll just show you example. You can go through this one later program. Here there is a one example. What it is saying is interface shared constants. Generally, I am saying whenever you are using a no, default value will be a 0. Whenever you are using a yes, default value will be 1. Whenever you are using a maybe, default value is a 2. Whenever you are using a later, then a default value is 3. Whenever you are using a soon, default value is 4. Whenever you are using a never, default value is 5. Right? So now these set of a constants will be common whichever class is implementing this particular interface, right? So if you are not doing in this particular fashion, then it will be confusing. Different classes might be giving a different values for these variables, right? So just to avoid that particular scenario, you will be introducing some constants in the interfaces, right? So that's it for the day. We need to discuss, this is a simple, you can we need to discuss nested interfaces, and we will be discussing that in our tomorrow's class, right? So till the nested interfaces we have discussed all the topics with respect to interface. So once I share you this particular recording, I'll be sharing a PPT also. Go through recording and a PPT. So PPT is having all the supporting examples also. So from tomorrow's class, we will be starting with the nested interfaces, right? You can leave the session. Have a nice day.